Let's take a look at a problem that you're going to see when you're working on the Math Excel here. Use the vertex and intercepts to sketch the graph of the quadratic function. If you're watching this, I'd encourage you to go back and watch the 2 or so videos that I've already done on writing this in standard form. We don't have to write this in standard form to get the intercepts, and that's the purpose of this video, is to talk about an alternative method. But if you do write this in standard form, you would see, you should end up with this equation. Okay, so we know that the vertex is at 6 comma 30. Okay, or I'm sorry, 6 comma negative 30, my bad. They want the axis of symmetry, which would be x equals 6. Okay, right, we get that from the vertex. It says use the parabola to identify the function's domain and range. Because the vertex is 6, negative 30, and because we see the leading coefficient both here and here is positive, we know that obviously the domain is still infinite, okay, and the range would be from its minimum point, which is negative 30, up to positive infinity. All right, you do enough of these problems, you should become more familiar with identifying all of this information just from this vertex. What I want to do in this problem, though, is I just want to focus on identifying the intercepts from general form instead. Keep in mind that the y-intercept, we've talked about this in a previous video, but the y-intercept is the value of y when x is 0, right? So the y-intercept is really f of 0 here, which when we do this, okay, the x terms disappear, and we're left with just this floating constant. Okay, so I mentioned this in a previous video, but in general form, the y-intercept is the floating constant value. Okay, so in this case, it would be 0 comma 6. Let's talk about the x-intercepts. The x-intercepts are the value of x when y is 0. So when the value of the function is 0. Okay, now we've got here this general form quadratic, right? And we've talked about how to solve this when you have the standard form set equal to 0, you add 30, take the square root, so on and so forth. But don't forget something that you probably would have learned back in Algebra 1, and that is the quadratic formula. Okay, the quadratic formula is used for finding solutions of x in a quadratic equation that is set equal to 0. Okay, and the reason I'm bringing this up now, specifically for right now, is because in Math Excel, I don't have the highlighter here, but in Math Excel, we want to pay attention to the blue font, because when they say use exact answers using radicals as needed, that means that we're not allowed to use decimals as a part of our solution. Okay, and one way to get radicals is by using the quadratic formula. So keep in mind, this is a method for solving for x when a quadratic is set equal to 0. So we take the opposite of b plus or minus the square root of b squared minus 4ac, and this is all written over 2a, right? So we end up with negative 12 plus or minus the square root of 144 minus 24 all over 2. Okay, I'm going to keep working down this right side of the page. So we have negative 12 plus or minus the square root of 120 over 2. All right. We have under the radical, 120 is not a perfect square, okay, but we do have a perfect square factor in here, so we always want to look for the largest perfect square factor of this number, and unfortunately, it's pretty small. It's just 4, right? So 120 is 4 times 30. So we end up with negative 12 plus or minus. We take the square root of this 4, which is 2, right? We pull that out of the radical, and then we're left with radical 30 here, over 2, right? And once we get to this situation, what we have in the numerator is both a sum and difference at the same time, right? Okay. So when it comes to simplifying this, which is what the program's going to want, we need to check to make sure that this number and any coefficient of the radical or any number that follows that plus or minus is divisible by 2. So both of these are divisible by 2, so I can factor a 2 out of the numerator. So what that looks like is we're pulling a 2 out, right, which leaves us with -6 plus or minus. The radical 30 is still hanging out. And then we have the 2 on the bottom. Now, since I've pulled this 2 out and it's being multiplied by something, I can cancel it here. You don't want to make the mistake of canceling them in this place just because they line up nicely in the fraction, right? This 2 is a part of this product, but it's also a part of a larger sum or difference. So I have to be careful and make sure that that's factored out before I cancel it. And that leaves me with -6 plus radical 30 as one of my zeros, and -6 minus radical 30 as my other zero. Okay, so these are our solutions for x when it's set equal to 0, which is our x-intercepts. Okay.